Lesson 2. Possible values of a random variable. To review, a variable is a characteristic or attribute that can assume different values. We use capital letters to denote or represent a random variable. In this lesson, we shall find the possible value of a random variable. To start, let us define sample space. A sample space is a collection or a set of possible outcomes of a random experiment. It is denoted by the formula S is equal to n raised to the power of r, where S is the sample space, n is the number of outcomes, and r is the number of objects observed. Remember, this formula will help us determine the number of total outcomes in our random experiment. Now let's consider this example problem. Suppose 3 cell phones are tested at random. We want to find out the number of defective cell phones that occur. Let x be the random variable representing the number of defective cell phones. What are the possible values of x? So for us to identify the possible values of x, we need to list the outcomes in the sample space. Solution. To each outcome in the sample space, we assign a value. Remember that the random variable x represents the number of defective cell phones in our experiment. So, if there is no defective cell phone in the result, then we assign the number 0. If there is one defective cell phone, we assign the number 1. If there are 2 defective cell phones, we assign the number 2. And if all are defective, we assign the number 3. Now let's look at the illustration. Remember that we are testing 3 cell phones at random. So we assign the letter D to represent the defective cell phone and N for the non-defective cell phone in the outcomes. Remember that X is our random variable representing the number of defective cell phones. First, let's solve for the sample space for us to determine the total number of outcomes in the experiment. So, the formula is S is equal to n raised to the power of r. Now, the value of n here is equal to 2 because in testing a phone, there are 2 outcomes. The first outcome is the D, which means the phone is defective, and N, which means the phone is non-defective. Now, the value of r represents the number of objects being observed. Now, we are testing 3 cell phones, so r is equal to 3. So, substitute S is equal to 2 raised to the power of 3. That's 2 times 2 times 2 is equal to 8 outcomes. Now, listing the possible outcomes or the sample space, remember that we have 8 total number of outcomes. So, here, there can be 8 possibilities in testing the phone. The first possibility would be that there are no defective cell phones and all of them are okay. The second is the third phone is defective. The third is the second phone is defective, and so on and so forth. So, listed here in the first column of the table are the 8 possible outcomes in testing a phone. Now for the value of the random variable x, remember that x represents the number of the defective cell phones. So we just have to count how many defective cell phones are there in the sample space or in the possible outcomes. So in the first outcome, n, we can see that there are no defective cell phones there. So we assign the number 0. For the second outcome, there is 1 defective phone. So we assign the number 1. And so on and so forth. Remember that all the values listed in the second column are the values of the random variable x, the number of defective cell phones in the experiment. So now we can say that the possible values of the random variable x are 0, 1, 2, and 3. Now let's try solving another problem. 4 coins are tossed. Let Z be the random variable representing the number of heads that occur. find the values of the random variable z. So this time, we will be looking at 4 coins that are being tossed. So first, we solve for the sample space. Hence the formula S is equal to n raised to the power of r. So the value of our n is 2 outcomes because when you toss a coin, there are 2 outcomes. The first outcome is the H, which represents the head, and T, which represents the tail. Now our R equals 4 because it represents the total number of objects being observed. So there are 4 coins being tossed. So we need to have R or 4 as the value of R. So substitute S is equal to 2 raised to the power of 4. That is 2 times 2 times 2 is equal to 16 total outcomes. So in the sample space, there will be 16 possible outcomes. Listed here in the first column are the possible outcomes when we tossed 4 coins. So we have H, 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 T, head, head, tail, head, 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 tail, tail, and so on and so forth. Now, for assigning the value of the random variable z, we just count the number of heads in the possible outcomes. So in the first outcomes, we have 4 heads. That's why the value of z there is 4. In the second outcome, there are 3 heads, so we assign 3, and so on and so forth. All the values listed in the second column under the random variable z are the values of our z. So the possible values of the random variable z are 0, 1, 2, 3, and 4. That's it for lesson 2. I hope you learned something about the possible values of the random variable. No words to ponder from this lesson. Life is full of possibilities, so never lose hope. Don't forget, have a statistic amazing day.